right, so here we have a multimedia company anticipates that there will be a demand for 20,000 copies of a certain DVD during the next year. It costs the company 40 cents to store a DVD for 1 year, and each time it must make additional DVDs, it costs $250 to set up the equipment. How many DVDs should the company make during each production run to minimize its total storage and setup costs? Okay. So let's start setting up first off variables because we'll need variables, and then after that we can kind of go from there. So let's say x is equal to the number of DVDs each run because we're gonna have to have so many for a run. Let's let y then equal the number of runs. Okay. Storage. We're gonna have to store them, it says. So storage is going to be equal to what? Well, if we have so many DVDs for each run, we're gonna have X, and then we're gonna have to take that and divide it by our 2. And because we're gonna have at least half a year probably, so we're gonna divide by 2 to get the average. So we have so many divided by 2, that's the average. Storage then is going to be equal to what? Well, we're going to have 40 cents per DVD times x over 2. And so 2 will go in here, and that'll be 0.2x. So that's going to be our storage cost. Now, if we take the number of runs each, number of DVDs each run times the number of runs and multiply those together, what does that tell us? Well, we know that there's going to be 20,000 then. Okay. So let's solve this. We've always been solving for x, so let's change it up this time. Let's solve for y. So let's do 20,000 divided by x. And so now we have to think about how many DVDs can be there in each thing. Well, when you do a DVD run, you better do at least one. If you do 0, that doesn't make sense to set up and get charged $250 and not do any. But the most we want to do would be the max demand. We wouldn't want to do more than that because then we're going to have to start paying fees beyond that. And so that would give us kind of a range for the number of runs based on X being, the number of DVDs for each run. So now what we can do is we can take and find the minimum cost. So the minimum cost, and let's call it of X, is equal to what? Well, it's going to be $250 to set up the um, equipment, and it's going to have this many runs, 20,000 divided by X. And then we're going to have a storage cost. So then we had plus a 0.2x. So that's the kind of the per run cost. That's the storage cost. Those add together to get our total cost, and we want to minimize that. And so if we multiply that, that's going to be 50, and then 1, 2, 3, 4, 5, and I think is all, and then divided by x. So, yep. And then plus a 0.2x. Now, first things first, find that first derivative. So take that to that. That's going to be x to the negative 1. So bring it down. So it's going to be a negative 5, 1, 2, 3, 4, 5. There we go. And then it becomes x squared in the denominator. This one just becomes plus 0.2 because that x becomes single x. All right, so now what we can do is we can say, okay, well, let's solve that for 0, or set it equal to 0. And when we do that, we get what? 0.2 equals 5 million. Do I have the right 0? Oh, 1, 2, 3, 4, 5, 6, one too many. Let's just rewrite it so I can make it so it's nice. 5, 1, 2, 3, 4, 5, 6. Here we go. And that was over x squared. So now we're going to do like we've done before. I'm going to multiply both sides by x squared. And then we're going to divide by the 0.2. or multiply by 1 over 0.2. And then what happens is that cancels that, that cancels that. And so when we go back to this, we get x squared is equal to what? Well, we're going to divide by 2, so that's going to be 2, 5, 1, 2, 3, 4, 5, 6, because we also have to move the decimal place one more, so we move it over one more, and then we have that. Square root of that's going to be a 5. We're going to have x is equal to a 5, and then we're going to have square root of that's going to be probably 3 zeros on it. So we have 6 zeros. Yeah, it should be 3 zeros. 5 and where's my marker? There it is. 3 zeros. Now remember, when you take the actual square root of that, that's going to be plus or minus, but we're not going to have a number of negatives. So it's only going to be positives here. So only positive for this one because you're not going to have a negative amount of DVDs on a run. So that's going to be kind of a key thing here. All right, so now it looks like we're going to maybe run out of room here. So then we need to find C double prime. All right, so that would be the critical numbers. And so now C double prime is going to be what? Pulling this up here again, that's going to be a -2 times that's going to be plus. So it's going to be a plus 2 times that. Uh, Let me see here what I get. Well, it's going to be 10 million, I guess. 1, and 1, 2, 3, 4, 5, 6 all over. And then it's now going to be x cubed. And what's going to happen here is it's always going to be greater than 0. And again, x has to be always, a positive number. So no matter what x we put in here, it's always going to be a big number here. And it's not going to be a negative. And so for all x, we're going to get a minimum, which is what we want. So that's good. All right, so now we plug in our critical point here, 5,000. And so C of 5,000 gives us what? Well, that's going to be what? 250 times 20000 divided by 500, and then plus 0.2 times 5123. And so that's going to go 4. That's going to be that's plus that. So it looks like it's going to be a at 0.2. That's going to be 2,000. So that's going to be $2,000. And so it's $2,000, but we also need to know what y is. Where's y? So this one, we have y of, and now we're going to plug in 5,000. Oops, not 50,000, just 5,000. And that's going to be what? Well, that's 20,000 divided by 5,000, which is going to give us 4. And it's going to be 4 runs per year. And then, so what else does it ask for? How many DVDs should the company make during each production run to minimize its total storage and setup cost? And so we're gonna run, we're gonna have N is gonna be 5,000 DVDs per run for 4 runs per year. And what else did we come up with? We came up with the cost. Where did my cost go? For a cost of $2,000. Okay, so then that kind of should get everything that they could even ask for, even if some of the stuff they didn't ask for, but it should be there anyway. Okay. All right, so again, it's another one of those that they didn't give us a equation to use, but we kind of worked our way through it, muddled our way through it, and we got our values here. So hopefully that will help you through this section.